Should be a pretty quick particle problem there. It gives us the velocity up at the top, and then it's asking us for the acceleration. We know it goes position, velocity, acceleration. So you're supposed to do the derivative of that, plug in the 3. The calculator do that for you, right? Math 8, that function there, don't take the derivative of that. The Math 8 will take the derivative of that for you and plug in the 3. So just make sure you practice it in the calculator, get that number right there. Then it says find the position. Remember, when you find a position, you got to always take into account the initial position. So at t equals 0, we're at x equals -5 right there. So that's why I start with my initial position. That's where we're at t equals 0. So you pick it up where you left off. This matches where that t equals 0. Like if they said t equals 1 was at -5, then I put a 1 right here. Okay, but that's our initial position at t equals 0. Pick it up where you left off, and then you're supposed to go to 3. So integrate that between 0 and 3. We know when we integrate the velocity, that's going to give us position. This just tells us how far we traveled in between 0 and 3, and this will give us our initial position there. So remember your initial position at t equals 0, and then integrate between 0 and 3 tells you how far you went after that. And then Math 9, that function right there, in between 0 and 3, and I will put in that -5 first, and then hit that Math 9 function. Now, what I want to mention here is when you start seeing positions and then you start seeing this stuff here, what you probably want to do at the beginning is graph this function in your graphing calculator. Not that I need the graph or anything, but if that's my y1, then instead of typing that function in every single time, I can just access like that alpha trace in my calculator, and I can do Math 9 of that alpha trace and hit that y1, or I get the absolute value and then hit that y1. So if you figure out, if you just have to do one of them, I probably want to mess around doing that. But if I have to do more than one, then it's worth my time probably to just graph it in my graphing calculator. Now, letter C, real quick, real easy. It just says evaluate both of those and interpret the mean of each one. You should know the meaning right away just by looking at it, right? That is straight from your blue packet right here. The integral of the velocity, that's your displacement. The integral of the absolute value velocity, that's total distance traveled right there. So immediately, you should be able to kind of write down what those things are, and then Math 9 that, Math 9 that, and it's going to get you that. And then rewatch that graphic calculator video if you need a refresher on how to do the absolute value bars. It's all in there, right? But that's, so if we're starting our blue packet, we know those instantly, the interpretation of those, and then you're practicing the calculator to get the correct number. And then the last part, we got a second particle, and it wants to know what time are the two particles moving with the same velocity. So I want to know when is this given velocity equal to the velocity of this guy. Now this is the position function of that second particle, so I need to take the derivative of that to get the velocity. So the velocity of this is the derivative, which is 2t minus 1, and I want to know when is that equal to this guy right there. Now when you have this is equal to 2t minus 1, that is a complicated equation to solve. You're not meant to solve that on your own, okay? Watch the graphic calculator video again if you forgot how to do this, but I have that whole function v, move everything to one side, set it equal to 0, graph that function in between like 0 and 3.5, and then let it find that 0 for you. Please watch that video again. Please practice it on your own because we got to get our speed up and our comfortability levels up with this one. But you graph that whole entire thing, that v minus the 2t plus t, graph that as your y1 or your y2, whatever, set that equal to 0, and then let that calculator find those zeros for you. Brick.